Again, problems like this are a little bit harder in the homework than it would be on the exam because step one is to come up with a balanced chemical equation. And we've got hexane, which is C6H14, that reacts with oxygen to produce carbon dioxide and water, and we have to balance that chemical equation before we can do anything. And in hexane, we've got 6 carbons here, so I need a coefficient of 6 here to get carbon to balance. Got 14 hydrogens, which means I need to have a 7 over here to get 14 hydrogens, and then that's where we run into problems. We run into problems because I've got 6 times 2, got 12 oxygen there, 7 times 1, 7 oxygen there for a total of 19. That's a problem for us because I need to have an even number of oxygens, right? I would need to put like 9.5 in there, but I can't use half numbers. I need to have a whole number. So what we can do is multiply the whole reaction by 2, and we've got 2 hexane, C6H14, plus 19 oxygen. It's going to go and produce 12 carbon dioxide and 14 water. Now we have a balanced chemical equation. Now we can take a look at the mass that we have in the reaction and then figure out what we can make based on that. So again, another variation of a limiting reagent calculation where we are looking for, again, the carbon dioxide in this reaction. So I've got 23.3 grams of hexane, 33 grams of oxygen, and I'm looking for the mass of CO2. So similarly to our previous questions, we're going to go from grams of hexane and oxygen to moles because I can't do anything grams to grams because they have a different molar mass. I can compare moles to moles. So we're going to get moles of hexane, oxygen, and then we're going to do the mole ratio to get moles of CO2. We'll figure out at this point which one is the limiting reagent, and then we'll carry forward with that one to find the mass of CO2 using the molar mass of carbon dioxide. So we'll start these calculations off. 23.3 grams of hexane. I've got 33 grams of oxygen. Right, oxygen is 32 grams for 1 mole. And hexane is approximately 86.18 grams per 1 mole. All right, so we've got about 0.27 moles of hexane and 1.03 moles of oxygen. We can't compare the numbers there. We need to get them both to carbon dioxide. So we go to the balanced chemical equation to see for every 2 moles of hexane, we are going to make 12 moles of CO2. And then for the oxygen, every 19 moles of oxygen, we're going to get 12 moles of CO2 out. So now we can get them both to CO2. Moles of oxygen cancel out, and I'm going to make about 0.651 moles carbon dioxide. Moles of hexane cancel out, and I'm going to get about 1.62 moles of carbon dioxide. Now we can directly compare those numbers, and now you can see that oxygen is our limiting reagent. Based on the oxygen, I would only make 0.651 moles of CO2, so the reaction stops there. That limits what we can make in the reaction. So it's only with the moles of CO2 from the limiting reagent that I want to carry forward with my calculation to see that 1 mole of CO2 is 44 grams, or approximately 28.7, so 2 significant figures again, because I've got 2 significant figures here. So I would say 29 grams of CO2 could be made in this reaction. Again, your problem might be slightly different. It's the steps. Mass to moles using the molar mass, and then moles to moles using the mole ratio from the balanced chemical equation. And then once we're in moles, we're right here. We can find our limiting reagent. And then once we identify our limiting reagent, we just carry forward with that number of moles because this is what limits the reaction. The reaction stops here at about 29 grams of carbon dioxide.